In this video, we will discuss about recursive pre-order traversal of a binary tree. So how can you manually find out the pre-order traversal of any tree? We have already discussed. And the code is also quite simple. Void pre-order, and we have passed here the address of the tree. Now if the root node is not equal to null, we will process first t of data, and then we will recursively call the pre-order with t of L child, and again we will recursively call the same function with t of R child. So we have already discussed pre-order is nothing but root, left and right. So the code is quite simple, but we will discuss how can this code is executed recursively. So we will process here recursive tree for this tree. So for example, this is simple tree P, Q, R, S, T, U and V. I have just assigned the addresses and left child addresses and right child addresses. So P, the address of this node is 100, address of this node is 200, this 300, 400, 500, 600 and 700. Now P, Q is the left child of P. So I have stored the address of Q here. And the right child of P is R. I have stored the address of R 302. And likewise this tree is I have just assumed. Now if you remember activation record, so here this is a recursive code. So by default, inbuilt stack data structure comes into picture. So why we call this function preorder recursive function with this tree, this T is pointing to this node, so T is 100. So in activation record, this is nothing but stack data structure, and one activation record with T is equal to 100 is created. And for example, preorder with 100, this function is called. Now T is not null because T is 100. First statement is printf t of data. So there are three successors of this node, but right now we will be printing this P. So P will be printed because t of data, and my t is pointing to right now here. Then next again recursive call with pre t of L child. So L child address is 200. Okay, so now one more new activation record with t is equal to 200 is created into this stack data structure. Now right now my t is at here, t of L child. Now we'll call this function pre 200. Okay, again same recursive call. So now pre 200 t of data. So t of data is right now this Q, so Q will be printed, and then again function call to pre its left child, so pre is equal to 400. Now again a new activation record t is equal to 400 created into stack data structure. Now from this right now my t is at 200, so this is completed. T of data is completed, T of L child is completed. Now my T is at 400. So now for this 400, the same function is called. It is not null. It will print T of data. So S is printed, and T of L child. L child of 400, this node is null. So the function will be called with the null value. And this is now completed because T is null. And again, as for this 400, call for this 400, T of data is completed, T of L child, that is null, completed, and pre of R child is also null. So this is completed. So for this t is equal to 400, this node, all the three statements are completed. So now the activation record is deleted from the stack for this 400. And now top of the stack is 200. So now t is pointing to this node 200. Now for this 200, T of data printf T of data is completed. T of L child is processed. Now T of R child. So T is 200 and R child of T is 500. So the same function called with pre of 500. So now my T is pointing to this 500. And the activation record T is equal to 500 is created into this stack data structure. So now we have this function call with T is equal to 500. It's not null, so it will print the T of data is now T. So T will be printed. Again the function call but with null and with null, because there is no left child of 500 and there is no right child of 500. So this is completed, this is completed. So T is equal to 500. All the three statements are completed. So the activation record is 500 deleted from this stack. So now for this T is equal to 200, all the three statements are completed. It's a printed Q. Then T of L child 400 is also processed. T of R child 500 is also processed. So now the activation record for T is equal to 200 is also completed. Now T is pointing to 100 again. So now T is pointing to 100. So now the third successor of this call of 100, now it will be called pre of what is the right child of 100 is 300. So the function is called with this 300 and a new activation record T is equal to 300 is created into this stack data structure. Now again there are three successor, but right now process this T of data 300 is R and the next function call pre with 600. So now T is equal to 600 is now created into this stack data structure and T is now pointing to this 600. Now this node is processed, so same function call, recursive function call with this data structure. So it will print T of data. So at 600 U is the node and next is pre with 0 because there is no left child. So this is completed, pre with 0, this is completed. So all the three things for this 600 is completed. So this activation record is deleted and now T is pointing to this 300. Now for this 300, T of data is completed, T of L child is completed, T of R child is remaining. So now T pre with the 700 is completed and now it will print V and its left child is pre of 0 and pre of 0. So now for this 700, it was created in stack data structure. It is now completed. So now we will back to T is equal to 300. For this 300, all the three things are completed. So this is also deleted from the activation record and now T is equal to 100. For this also T of data is completed, T of L child is completed and T of R child is completed. So this is also deleted from the activation record. So now you can see the order. First P is printed, then Q, then S, then T. Okay, then we came back here, then again U, then R, after that R, U and V. So P, Q, S, T, R, U, V is the correct pre-order for this tree.